this video, we will explore regression analysis. Earlier, when we discussed correlation, we learned that it measures the direction and strength of a linear relationship between two quantitative variables. However, correlation does not provide a mathematical relationship for making predictions. In the business world, prediction is a key aspect of many human activities, such as forecasting crop production, consumption, prices, sales, income, or profit in the business world. Similarly, governments rely on predictions of population growth, agricultural consumption, rainfall, or revenue for effective planning. When two variables are significantly correlated, we can use this relationship to predict the value of one variable based on the other. This is the basis of regression analysis. Regression analysis is a statistical technique used to examine the relationship between variables. To perform this analysis, researchers collect data on the variables of interest and apply regression methods to estimate how one variable depends on another. In regression analysis, there are two main types of variables. Independent variable used to make predictions. It is also referred to as the regressor, predictor, or explanatory variable. Dependent variable whose value is predicted based on the independent variable. It is also known as the regressed or explained variable. The independent variable is always represented on the x-axis, while the dependent variable is shown on the y-axis. For this reason, the independent variable is typically denoted by x and the dependent variable by y. Let us understand the meaning of independent variable and dependent variable from the following illustrations. In case of advertisement cost and sales, an increase or decrease in advertising costs usually leads to a corresponding increase or decrease in sales. Therefore, advertising cost is considered the independent variable x, while sales is the dependent variable y. In case of rainfall and yield of rice in some region, it is very clear that yield of rice depends on rainfall, so we shall take rainfall as independent variable x and yield of rice as dependent variable y. Types of regression. If the scatter diagram shows some relationship between independent variable x and dependent variable y, then the scatter diagram will be more or less concentrated around a curve, which may be called the curve of regression. When the curve is a straight line, it is known as the line of regression, and the regression is said to be linear regression. If the relationship between dependent and independent variables is not a straight line, but curve of any other type, then regression is known as nonlinear regression. Regression can also be classified according to the number of variables being used. If only two variables are being used, this is considered as simple regression, whereas the involvement of more than two variables in regression is categorized as multiple regression. Regression line. When we discussed correlation, we focused on measuring the direction and strength of a linear relationship between two quantitative variables. Regression, on the other hand, involves drawing a line on a graph to represent the pattern of the data. This line is called the regression line. A regression line indicates how y changes when x increases by 1 unit, either increasing or decreasing. For instance, if advertising cost is on the x-axis and sales is on the y-axis, we would typically expect a positive relationship. The more you spend on advertising, the higher the sales. However, if advertising cost is replaced by product price, a negative relationship may be expected, as higher prices could lead to lower sales. In linear regression, we identify the best fitting straight line through the data points. There are two methods for fitting a regression line: method of scatter diagram, method of least squares. Method of scatter diagram. Consider n-ordered pairs of observations for two correlated variables, x and y, represented as x1, y1, x2, y2, xn, yn. Using this data, we create a scatter diagram by plotting these points on a graph. A regression line is then drawn to closely follow the pattern of the data points. If y is the dependent variable and x is the independent variable, this line is called the regression line of y on x. This line can be used to estimate the value of y for any given value of x. Since this method involves visually drawing a line without complex calculations, it is a quick and simple way to fit a regression line. However, a major drawback is that different people may draw different lines based on their judgment. As a result, the predicted value of the dependent variable y may vary depending on who draws the line, leading to inconsistent estimates. A regression line drawn using the scatter diagram method is not the most accurate because it does not ensure the best possible estimate of the dependent variable. To obtain the best fitting regression line, the method of least squares is used. In the method of least squares, the goal is to find the regression line that minimizes the total error between the actual data points and the values predicted by the line. Here's how it works in detail. Calculate the error's residual. Square the error's residual. Calculate the sum of squared errors. For each data point, xi, y high, the actual value of the dependent variable is y high. The predicted value from the regression line is denoted as y hat I. The difference between the actual and predicted value is called the error or residual. When the actual value is above the regression line, the residual is positive. When the actual value is below the regression line, the residual is negative. By squaring these errors, we ensure all differences are positive and prevent cancellation between positive and negative errors. Error residual equals y hat minus y hat I squared. Calculate the sum of squared errors, SSE. For n data points, the total error is the sum of the squares of all residuals. Apply the method of least squares to multiple lines. For instance, we could draw 4 other lines. However, the sum of the squared residuals for any of these lines will always be greater than that of the original line. This is why the original line is considered the line of best fit. This line gives the most accurate estimates of the dependent variable for any value of the independent variable. This method is objective and consistent, meaning everyone will get the same regression line from the same data. The best fitting regression line is represented by the equation y hat equals a plus bx, where b is the predicted value of y's tau, a is the y-intercept, value of y when x equals 0, b is the slope of the line, how much y changes for each unit increase in x. B is also known as regression coefficient of y on x. The least squares method provides formulas to calculate a and b. The value of a, which is the y-intercept of the regression line, is calculated using the formula a equals y bar minus b times x bar. B equals the sum of x minus x bar times y minus y bar divided by the sum of x minus x bar squared. Y bar represents the mean of the y values, x bar represents the mean of the x values, and b is the regression coefficient of y on x. So b is also calculated using the formula, numerator, n times the sum of x times y minus the product of the sum of x and the sum of y, denominator n times the sum of x squared minus the square of the sum of x. When the correlation coefficient r, the standard deviations of x and y, and the means of x and y are known, the regression coefficient b is calculated using the formula b equals r times standard deviation of y over standard deviation of x. Let's do one example. The following observations are obtained for life, years of usage, of cars and their average annual maintenance costs of a specific model of car of a particular company. Obtain the regression line of maintenance cost on the life of cars. Also estimate the maintenance cost if the life of a car is 10 years. The regression line of maintenance cost y on life of car x is y hat equals 5 plus 3.25x. Since b equals 3.25, we can say that every year, 1 unit change in x, the maintenance cost of the car increases by approximately 3.25 thousand change in y. When the life of a car is 10 years, its estimated maintenance cost is 37.5 thousand. To study the relation between two variables, yearly income, X of a family, and their yearly investment, Y, in mutual funds, the following information is shown for a sample of 100 families of a city. X equals annual income of a family, lakh in res. Y equals annual investment in mutual fund of a family, 1,000 in res. X bar equals 5.5, Y bar equals 40.5, S sub X equals 1.2, S sub Y equals 12.8, R equals 0.65. Obtain the regression line of annual investment in mutual fund of a family on their annual income. Estimate the annual investment in mutual fund of a family whose annual income is Rs 4.5 lakh. Feel free to pause the video so you can try this question for yourself. Thank you for watching. If you found this video helpful, feel free to like, subscribe, and share it with others who might benefit. Thanks again, and we'll see you in the next video.